I've started a new project and I'm very excited. I'm going to be using this Tiny 2040. This microcontroller is based on the same RP2040 chip as in the Raspberry Pi Pico, but as the name suggests, it's in this tiny form factor, smaller than an SD card. It supports Circuit and MicroPython and has pin compatibility with the Pi Pico, which I think will be important for using the PIO state machines of the RP2040. The reason I want this small form factor is because I'm building a parasitic device which will plug into and be powered from another device. One of my design requirements is I want this to run off 3.1 volts at very low current draw. Now, the datasheet for the Tiny 2040 is suitably vague on whether that will work, and that's understandable because, like any general purpose processor, the power it uses will be based on the tasks that you program it to perform. So I'm going to program this Tiny 2040 to run a demo task flashing the LED, and then I'll do an experiment with some AA batteries before I hook this thing up in anger. And that's what we'll see in this video today. This is my time-lapse rig that I have rebuilt. It's still a Pi 3, and on the back, if I fold it over, it has the Pi camera plugged in, and it's mounted up with these 3D printed parts onto a 7-inch touchscreen display. I updated the OS. This is now running Bullseye, and that has the new camera libraries on, so I had to rewrite the Python scripts I was using for capturing time-lapse as well, but I'll just bring up the preview window, and here you can see a preview images coming in from that camera mounted on the back. So that's what I used to capture the time-lapse for this project. One of the coolest things I discovered is that I can use Visual Studio Code with an extension on my daily driver machine and develop on the Pi over SSH. Having the file system visible as if it was local and being able to run the Python scripts on the Pi and capture from the actual camera and view the images on my daily driver machine, I was able to iterate really quickly on this. I really enjoyed this as a way of developing. The Git controls within Visual Studio Code also worked, which made it much more convenient to save the changes I was making on the Pi back to my repo. One thing I didn't try was debugging, connecting a debugger from this session across SSH. I must try that next time because that would be really awesome. Okay, so here is the Tiny 2040 powered by a pair of AA batteries sat in front of the time-lapse rig with a watch so I can see time ticking by. But before we talk about that, let's have a quick look at something I shot during setup. Pimoroni Tiny 2040, and I'm powering it from this pair of AA batteries, and I want to see how long it's going to run for. Connected up to the multimeter, and it's flashing the LED, which is using a fair amount more current than the actual processor I expect, but it's drawing around about 0.2 milliamps, could be microamps, gonna guess milliamps. I will check that. And here is the time-lapse video that I shot of this. It started at 4 in the afternoon, running the program, flashing the LED and drawing current from those batteries. And I left it running throughout the evening and through the night. I set the program with an initial runtime of 12 hours, figuring I could extend it if I needed to. Now, when I had some time in the evening, I did go and double check those multimeter readings, and it was drawing between 0.2 and 0.4 milliamps to execute the program. So I sat and did a little bit of maths to work out what that meant. So this chart represents 1 amp with 10,000 pixels. I've coloured in the first 4 pixels top left in pink, which represents 0.4 milliamps as a fraction of 1 amp. This chart shows an amount of energy in amp hours. The 10,000 pixels represent 1 amp hour, which is 1,000 milliamp hours. The time-lapse video ran for 12 hours with a peak current of 0.4 milliamps, so we can conservatively estimate that we drew about 4.8 milliamp hours, which is shown in purple at the top. So how long would we expect it to take to exhaust the two AA batteries? Each AA battery is rated to hold 2400 milliamp hours of charge, so the two batteries combined can provide 4800 milliamp hours of charge. If the Tiny 2040 continues to draw a peak 0.4 milliamp hours, then we should expect a runtime of at least 12,000 hours off these batteries. The amount of energy I estimate we've already used during the time lapse is shown at the top of the very left grey bar. So assuming my maths is right, which is a bit questionable, there's both good news and bad news. The good news is that these numbers are great for my project. It shouldn't be a problem to draw this much current from my device. The bad news is that this time lapse is 1,000 times too short to show anything interesting. But I'll let it play out because it's kind of therapeutic. Well, I'm sorry the time-lapse wasn't more informative, but it's useful to know we can get such a long runtime from a pair of batteries, and hopefully that will bode well for the rest of the project. Anyway, thank you for watching and stay safe.